Hello, everybody. Thank you for joining us. We really appreciate you being here, and we hope you will get valuable information from today's webinar. This is the first in the OSDFCon webinar series, so we're really happy you joined today. This webinar is being recorded, and we'll be emailing out the link tomorrow to everyone who registered, so if you find it useful and informative, please feel free to share it with anyone who might be interested. Before we get started, let me introduce myself. I'm Allie Devine. I'm the event manager at Basis Technology, and I'm just going to go through some logistics before we officially get this started. So first, in your reminder emails for the webinar, you should have received instructions on how to get everything up and running before this webinar. So if you somehow missed that, please look at that document now. You should find that either in the handout section of GoToWebinar, or you can head to the link that's located in your reminder emails. Now, you probably already noticed, but everyone is muted. However, the intention is for this to be an interactive webinar. So there are 3 ways that you can participate. First, if you haven't already, we suggest you head over to the open source DFIR Google Slack channel. The link and instructions are also in the document I just referenced. If you're just joining us, you can find that document in the handout section here or in your emails. Once you're in that workspace, you'll also need to add the channel called Saucinar. That channel was created for the purpose of this webinar, so that is the best place to go during this hour. So the Slack channel is the best place to ask questions. If for any reason you're unable to access the channel, you can also ask your questions here in the GoToWebinar platform. To submit a question, just type it into the questions pane of the control panel. Now, if during the webinar you close that out, to get it out of the way, you should be able to find it again by either finding the orange arrow and clicking on it to expand the control panel, or you can find the GoToMeeting toolbar under the window, under window in the toolbar, and you should be able to click to add back the control panel. So lastly, regarding questions, if you'd like to speak your questions aloud and don't have a problem with us recording your question, you can raise your hand in the control panel and we can give you permission to speak. So if you have questions anytime during the presentation, please feel free to ask them throughout. They will be addressed during the webinar as well as at the end. Now, when the webinar ends, you'll be directed to a survey. We would really appreciate it if you could just spend a couple minutes letting us know your opinion. It does really help us learn what you thought of this webinar and also what we should do on future webinars. Now, as mentioned before, I work for Basis Technology. We've been around for 25 years, and our digital forensics team focuses on building easy-to-use software for the people who are on the front lines of cyber. Now, as the event manager, it would be irresponsible for me to not tell you about our annual event every year. Because we are very supportive of open source tools, we hold the Open Source Digital Forensics Conference, also known as OSDFCon, every year. So if you don't know about it, this year it's taking place virtually on November 18th. It's free for everyone to attend, so if you'd like to get more information, register for the event, or check out more of our upcoming webinars, go to osdfcon.org. So without further ado, let's get started. I want to introduce you to Kitty, Alex, and Ryan, who will be spending the next hour with you to talk about Timesketch and Jupyter. So please take it away and introduce yourselves.
All right, hi, my name is Christian Guðjónsson. Some people might know me. I've been working for Google almost since forever. And I'm in the forensics team there. I've also been known for dabbling in coding, plaso / local timeline, and now with Timesketch. Fun fact about me, I've also been known as Christina Johnson by some Twitter reporters, for those who can get that joke. Anyway, Alex?
Yeah, so I'm Alex, joined the digital forensics and incident management team back in February and spent like 8 to 9 years before at a different company doing forensics and incident response. Besides that, I'm also part of the board of directors of FIRST. And fun fact about me, I don't have a fun fact right now, so don't have fun anyway. Ryan.
Hey, thanks, Alex. Hey, so my name is Ryan Benson. I also work at Google as a security engineer on the digital forensics team. I've been here 2-ish years, 2.5 years, but I've been doing stuff in digital forensics field for over 10 years, all kind of bouncing around from different companies, including Strauss Friedberg and Mandiant. And I like to work on open source tools in my free time and now in my work time at Google, so it's awesome. One of my focus areas is doing things with browser forensics.
All right, and today we're going to be exploring Timesketch through the wonders of colab and/or /Jupyter. And we're going to be doing that by solving an open source forensic challenge, which is going to be the infamous case of the stolen Szechuan sauce. We'll start by doing a quick introduction into the world of pandas and notebooks before we can start to introduce our challenge and then ultimately dive right ahead and solve it. To be honest, I mean, this would absolutely be best to have that in a 4-hour format, where we'd all be sitting together in a room and we could walk between everyone and help each other out. Unfortunately, that's not an option now. We're stuck with this virtual format, so we're going to make do with an hour. We might stretch it a little bit, but we're trying to keep it roughly around an hour. But I also want to have this as interactive as you can. That's why there are 3 of us right now. Only one is going to be talking at any given time, whereas the other 2 will be monitoring the Slack channel for comments and questions. And we will be keeping that channel of communication open even after this webinar is over, so that people can still continue to work on this and ask questions. So please feel free to do that. Have your notebooks open, follow along, ask questions along the way, try things out. If you don't understand something, please ask. That's what we're here for. But the first question really is that, you might often ask yourself, what really is Jupyter and Colab, and should I really be afraid of it? I want to, first of all, clear the air. You should absolutely not be afraid of it. Just try it out, and I'm sure you will be surprised. I'm going to warn you that, with this, as with everything else in life, there's going to be an initial learning curve. It might even be slightly bigger for this tool than for many others. But once you get past it, you may never want to return back to using anything else. Jupyter and Colab are essentially web-based front ends of an IPython notebook. So before we can start talking about Jupyter and Colab, we have to know what an IPython notebook is. IPython stands for Interactive Python, and you can look at it as a kind of a different type of an interpreter for Python code, one that evaluates Python code interactively, line by line. Does that mean that you need to know Python to be able to use this? It kind of implies it, but you don't need to know a lot. You just need to know the bare minimum or basics for this to be very useful for you. So don't be afraid of that, and then you can just pick it up as you go. The more you know, the more useful it will be, but you don't really have to know a lot. A notebook, on the other hand, is a type of interactive document for code. It's a mix of text cells and code cells, where the text can be formatted, for instance, in Markdown, and the code you write will be interpreted depending on the kernel or the runtime that you attach it to. Notebooks in Jupyter and Colab can use different runtimes, so you could actually have, it doesn't have to be Python, but in this case, we're going to be using IPython as our runtime. So we're going to be using Python here. But let's take a look at one of these notebooks here. This is a notebook that's hosted on our Picatrix project, and Picatrix is just a small open source project at the moment right now that's trying to aim for making Colab and Jupyter more accessible to security analysts, providing some helper functions that can help you along the way. We're not going to really go through all of this notebook right now. It's going to be going through the very basics of pandas and numpy, which are the most important libraries here that you really have to know. All of the development of both pandas and numpy is driven by the data scientist community, which happens to be much, much larger than the small niche of a community that we, the forensic community, are part of. So we can really benefit from the development that they're doing. And if you look at all these tools, they're all designed to work with large quantities of structured and unstructured data that may or may not be text. And they are trying to make tools that can make sense of these data. And for me, that rings a lot of bells. And when you start using it, you can actually find out that a lot of these tools that they're using for their data science purposes is very useful and comes in handy when you're dealing with forensics. So I'm not going to go up to you through all of this notebook. I'm just going to lightly introduce it. As I go through the notebook, if you haven't already, it will tell you how to run Colab or Jupyter. It will tell you how to install files. It will tell you a little bit about just the bare minimum basics. And we're gonna assume that you've gone through this and that you are familiar with what a panda is before we move ahead into the analysis section. I just want to make sure that everybody knows, what the panda data structure kind of looks like. And you can look at it as a somewhat similar to a SQL table or a sheet in a spreadsheet. That is, we have a table of rows, and each row will contain a column, and the column will have a data. And then you have some sort of operations on these rows and columns, and you can do select statements by filtering the data set, or you can do join operations by using merge, et cetera, et cetera. So you can do a lot of the same things you can do with sheets or pivot tables or with SQLite databases. But so without further ado, I am going to hand this over back to Alex to talk about our use case.
Cool. So the case that we picked is the stolen Szechuan sauce. This scenario was created by James Smith, so kudos to him for making this challenge and putting up the evidence. Kitty, can you move to the next slide? So if you go to the website of the challenge, you will find 2 EO1 images, a PCAP, some memory images, and some CSV files that were created by digital forensic tools. So a really realistic scenario of what you find when you start a case. The goal for this session is to show you how to approach such a case with free and open source DFIR tools. Promise we will not going to answer all the questions, and we will also show you some mistakes and problems along the way that we encountered and how we try to solve them. So it will not be a run this and you will have all the answers. This is the idea of this session. Okay, next slide. The tools that we're going to use are Plaso, log to timeline. We will also leverage Timesketch, and as Kitty already said, colab and Jupyter. And the next slide, you will see how to participate. So as Ali already outlined, ask questions on Slack. Open the notebooks, primarily the analysis notebook, because with that you can just connect to the cloud kernel and connect to our demo Timesketch instance where all the data has been published already. So you can just run it and see what happens. And with that, I think now it's demo time. So let me show you my screen. Okay, first off, we will show you how to import some of the data, but not all. For this, we created a dedicated notebook that is called Data Upload. On top, we have a little description. And then if I want to run the first cell, I just click Run, and it will do some imports. And the first file we will focus ourselves on is a CSV file that is provided with the case. It's called autoruns desktop and then the hostname.csv. So we will just set a path and the file name and try to read it. Now, of course, we want to have a look at what is in this file. So let's just see when we try to print out the first lines. And we see that something is wrong. This doesn't look really good. There are some skipping errors, and this looks weird, right? So let's look at the first few lines to figure out what's going on. And here you notice already that there are some odd question marks. So if you use DD to print out the first few bytes, you will notice that this is, someone wants to zoom in a little bit, no problem. That this is not UTF-8, but UTF-16. So let's try to reread it again, and this time as UTF-16. And this looks much better. So now we can see actual content from the CSV. And as you see, we already have it as a pandas data structure. So it already recognized the first line as the titles of this, which is already handy. The first thing you will notice is the time from the CSV is not really what Timesketch would expect. So we need to focus on that and correct it. We set the time column to the actual time data type, and do some other massaging of the data, because Timesketch expects a message column. So we generate a message column with some entries of other columns. And here you can see that we now have a message. There should be a message column now. And if you then do a df info, you can also see that there is the message column. And we see that the date time column is now also from the data type date time. So this is important and nice to have. So now let's try to upload this pandas to Timesketch, because that's our ultimate goal. We create a Timesketch client, and let's just display what sketches are in this example on my local instance. And here you get back the sketch ID 1 has the title secret Szechuan sauce. That's nice. And this is the sketch we want to use. So we set the sketch ID to 1, and we will now use the Timesketch importer from a library that we maintain that makes it a lot easier to import stuff. So we just pass the sketch. We say we want to import data, we give it a name, and we add the data from the pandas data frame. That should be pretty easy. But if we run it, it will run into issues. So if we now move over to Timesketch, you see that we have here an error. And if you look closer, you see that there is something with non-type, and it's in the datetime column. This is usually an important field for Timesketch, because everything is around datetime for Timesketch. So if those values are missing, the tool cannot work. So let's go back to our data frame and check which rows don't have a date time. And here you see that we actually have quite a lot, like 22 columns without a time set. And this is problematic. So if we now do some massaging of the data, which I will not go into much detail, but basically we just filter out every row that has a not available row here. We try that again, and then we don't have an issue. So if I go back to my Timesketch instance, it says running, and here we have the data. And we have all the rows with a set date time in here, and all the various columns as well. So this is pretty nice. And we can do the same thing for the other CSV, because we kind of expect that this is the same format. We can just use the same code we used before. Just run it and do it again. And if we now move back to our Timesketch instance, go to overview, we see that the other CSV file also has been imported. Pretty cool. So we only needed to solve the formatting and the datetime issue once. and then we can just reuse it. The next thing you want to have in your environment is the plaso files from the EO1. So what we basically did, just ran the EO1 images with plaso, and then either upload them with the Timesketch importer CLI tool, or using the importer again, which I will not do here, because for the next collab, we will just focus on the demo instance where we already uploaded the plaso data to. And last but not least, there is also the PCAP file. The PCAP file is a little more tricky, and this is because there are basically two ways to import the PCAP to Timesketch. The first one is use Wireshark to like parse the PCAP and export it to a CSV file, and then like use basically the same method we already discussed and import it as a CSV, or use existing Python libraries to parse the PCAP and then extract some fields and maybe get a little more data out of it. So if you go further down the notebook, you will have an idea of both of those ways. But we want at least the parsing with Python might take quite a bit of time. So I think for us, when I tried it, it was like 4 hours to parse it. So that's why we pre-prepared that for you. Both options are already on the demo server, and you can play along and see the difference of the granularity of detail that a CSV brings you, or if you like parse every packet. Of course, you could also limit the amount of data that needs to be parsed if you, for example, filter out the PCAP already with Wireshark and then export it to a smaller PCAP. But that's basically all you need to do to import the vast majority of the data. The only thing that we didn't cover here is the memory image. But if you are excited about that, you can just, for example, parse it with volatility, and then you have a CSV and you can import it. So there are lots of opportunities there as well. And this is all we need to do to import the data. And now I would hand back to Kitty to go into the analysis and explorational thing of the talk.
Better to unmute too. All right, so we go back into the analysis section now. Now that we have actually uploaded all the data that we need, everything is in Timesketch, and you can, if you want to, you can go through Timesketch and try to look at it. But obviously, we're going to be using just Colab here. So we have the analysis notebook that you can open up and start going through. I'm not going to go through all of the code here. I'm going to go through a little bit of it and try to explain it, and then hopefully get some questions or get some people comments from people, and then we can go through those particular sections a little bit in more details. So first of all, if you are looking at this in Colab, you will see that we have things look slightly nicer in terms of we have these forms and markdown. This is a code that you can hide and show just by saying show code, and you can see the code that's behind it. Basically what we're just doing here is we're just loading up the libraries here. And here we're configuring VirusTotal. So one of the things that you need to do is you need to add in your VirusTotal API key in here, so that it is saved, so that you can use it a little bit later on. The first thing that we really do, we need to go, when we're doing the analysis, we need to be able to connect to Timesketch. So for that, we need a copy of our Timesketch client, API client, which is basically an object that you can use in Python. For the first time you connect to it, it will ask you a series of questions, and here are the answers to them that you can answer. Once you've successfully answered them, it will save the configuration to your home directory. So the next time you're connecting, you don't need to enter any of these questions. So just for your information, So the next time you try to run it, it won't ask any questions because it already has, and it has everything saved. So we wanna, here in this case, I just print out all of the sketches, and I'm just looking for a sketch that has the name of Szechuan because we don't know what the sketch ID is beforehand. If we would know that, we would just be able to say that directly. What we're going to be doing now, we're going to be using Picatrix magics. So magic is essentially just a small exported function into a notebook that you can use, and it will help you. It's like a helper functions that you can use throughout the code, and we'll be using them a little bit. So you can see here, what I do now is I say for Timesketch, set the active sketch. So the sketch that we're working on is going to be sketch number 6. So as soon as I hit that, all of the other Timesketch magics are going to be working, and assuming that we're going to be using this particular sketch. So you don't ever have to reconfigure that or tell the tool that again. We can now start looking at the questions that we had for this particular case. And the first question that we had was what's the operating system of the server? And if we want to go and head, well, so some of this stuff that we're doing now also does kind of imply that you know a little bit more about plaso and how things are stored. In this case, we're going to be saying, give me everything from the parser win registry / the Windows the registry plugin called Windows version. You can also just say, the actual key, registry key, and it will fix that for you too, or fetch that for you too. If you don't know the field names, you can also use wildcard. So here, I specifically say, give me back the data that has these particular fields in it. I could also just say, give me back everything. And oh, the token has expired. Let's go back here. That's because I ran this a long time ago. Sorry about that. Let's fetch this again. And now let's run this query again here. Token has expired. Let me get that. Sorry about that. I'm gonna go. Just because I ran this such a long time ago, that it had expired everything. So anyway, now when I do this, I actually have now back all of the fields, all of the columns in there. So I don't have to actually know them all. And now you can get a lot more columns back. But in this case, we are really only interested in the host name and the product name. So for that, we can do the name of the Panda data frame, and we can do these double brackets, and then just a list of what columns or fields we want to be displayed. And here you can see, the host name and the product name for all of the responses back that we got from a query. From there, what we can do is we can start using some of the summary tools that Pandas provide us with. So what we can do is, first of all, if we can say the current data frame here, and we want to filter that data frame out, because the question is, what is the operating system of the server? So if we want to say, oh, I only want to know the results where the hostname field is set to Citadel DC01, we can just say, here, the filter the current data frame using the values where host name equals to this value here. And that here would give us all of the entries where that is true. We can then further say we want a specific product name. We just want to look at the product name itself, because that's the one that we're interested in. And then we can say either unique to get all the unique values, or we can just say value count. And value count will take this field or this column, and it will do a unique on it and a count. So count every option here. So you can see there, Windows Server 2012 R2 standard evaluation appears twice in this data frame.
And here it's important to note that the data that Kitty is playing with is like in the client. So it's not querying the Timesketch backend again. It's all the data that's already stored in the pandas data frame.
Yeah, so I already fetched the Panda data frame, and I'm just working with that now. And the same here, I can just go now, oh, what's the system of the desktop? We already have that. Now we just have to switch the host name to a different field here. And we get the same thing. That's a Windows 10 enterprise evaluation. Same thing now again, what's the local time of the server? Here we can just say, oh, give me query Timesketch. And here you see these queries. These are the same queries you would put in the UI. So these are the exact same queries you would have in the UI as you have here in the API client. And again, you can either say fields equal everything or indicate what fields you want back. Here we do a, let's give me all the system select, and we want just from the host name where the Citadel DC101 is. Why are we doing this? Because we want to go and we want to see what is the current control set of the operating system. So first we just say, give me the select key for the Citadel DC01 server. And you can see here, here's the key, its key local machine, system select, and here are the values for it. We could obviously read it out ourselves, or we could, if we want to, start using more of the pandas options that we can do here. When we do what we do here is that we take the panda called current DF, which is the data frame that we had. We're going to say, give me the column values, and the values here is what contains here. And we want to apply string operations on one of it. So we do .str, which means that now we get access to string operations. And then we say extract. And from extract, we can just do a regular expression with a parenthesis, and the parenthesis will be what it's extracted. And from that, we get a table saying, oh, the current value is set to 1. Now, since we know that, we can now go back and query the time zone information. And in the time zone information, we can look at the key path where the current control set is 1. So again, we go back and we filter that data frame, and we say key path will contain control set 1, and we just want the configuration value. And the configuration value here will be, slightly long text. We can just read it and see time zone information is specific center time, or we can, use some Python code and do it slightly prettier, and we can go through the code and extract it into its own data frame, where now we have each column with a value. And then we can see the active time bias, and a little bit easier to read. So this is just one way of where we're just doing the query into Timesketch, get back this data frame, and then we can start looking at the data frame and start trying to manipulate it, filter it, modify the values. And the string operations are the ones that you're going to be using quite heavily, and we're going to be using some of them, more of them in the webinar below. And the first question that we get is, what was the initial entry vector? How did they get in? And in this case, we're going to be assuming that they got in somehow through external sources. So we're going to be doing some statistics on the network data because we have network data. For that, we want to maybe do some aggregations. And there are two ways of aggregating data. First of all, we can use pandas aggregations. And if you want to do pandas aggregation, what we would have to do is we have to query all the data, get it back into Timesketch and into colab, sorry, and then from there aggregate the data. Or we can take advantage that Timesketch runs with an Elasticsearch backend, and we can just use the aggregations of Elastic. So for that, the first thing we need to do is we just need to list up what are the available aggregators that we have available to us. And aggregators are just aggregations that you can see in the UI as well. When you do aggregations, you can see that there are two options that you have called field bucket and query bucket. The only difference here is that a field bucket is you just aggregate a particular field, as in, oh, give me the top 10 domains. A query bucket is the same thing, except you apply a query ahead of time. So you can say, filter out everything that has the URL evil.exe, and then aggregate and give me all the domain names from in there. So these are the two options. And when you do this, you can see, you know, the description, you can see the name, and you can see what parameters you can use. You have to run it. So it's field and limit and so on. So if we want to do this and we want to produce a graph or aggregation, we'll just say we're going to use a field bucket. So we're just going to take one parameter and we're going to aggregate it. And in this case, we're going to use the source, which is the source IP in the network data. We're going to limit it to just the top 10. And we're going to be using a horizontal bar chart. You can see what's available here. And you can just play with that if you want to. And then you run it, and then you get back the chart. And you could do, you know, you can change this to circle chart, and you would get it back like this. Not as useful in this case. I think probably easier to read it as a bar graph. And you can see if you hover over it, you can see the IP and the count. And you can see that there's one particular IP here that stands out, only one external IP here. You can also look at this as a table if you want to have it as a data frame, and then you can work on it and do whatever you want to with the data frame itself. We can do the same with the destination field, and you can see here again, there's one particular internal host that seems to be the most popular here, and there's an external host here, the same IP as we saw before. So you might want to take a little bit closer look at that particular IP address. So for that, we can do a query and say, oh, give me all the records where the source IP is set to this particular IP that we saw. And just to further limit it, we can only want to look at the data type where we have the Wireshark PCAPs. And then you can see the data, and you get a lot of data back. In fact, you get like 40,000 records back. And if you actually look at it here, you actually get back 128,000 records. But it returns only the first 40,000 back. So if you actually wanted to get all of the records back, you would have to go here and press max entries, change it to something bigger, 115,000, something like that, and then rerun it. That's just to limit, because sometimes you might make a mistake and you might do, you know, a wildcard query, and you don't really want to fill all the memory of your machine or put all the load back on the server. So we limit the return set that you get. But if we do limit it, a warning like this will be printed out so that you can go and say, oh, okay, I didn't get all the data back that I could have. And then you can just correct it and rerun the query to get the data back. But if you start looking at it, now we're going to show you how you can do queries or aggregation based on pandas and how pandas operate and work. So for that, we're not going to be using group by. So what we're going to take, we can take this data frame here. You can see it here with all the data in it, and we're going to say, we're going to do a slice of it, just contain 3 fields here, and we're going to group by 2 of them. We're going to group by destination port and destination. Basically, what I want to get is I want to get how many pairs of destination port and destination IPs have we seen and count them. So you can just do this, and you just have to add one more column, and this can be, it doesn't really matter. This one here is just irrelevant. It just has to be a third column so that the group by can convert that to a count or a mean or anything we want. So when we have this here, we get back a group object. And we can then do, so we do this, we get this group object here, which is called count. We can also do sum, or we can do mean, or oh, this one doesn't have mean here. No numeric types. Okay, but you can do, because it's not a number. So you can see here, it just summarizes everything. It just pluses. So you get a lot of crap here. But basically what we're doing here, we're counting. So you can see that here for that destination, right? We looked at everything that comes from that particular IP, where that IP is the source, and then we're going to group on pairs on the destination port and destination. We can see that almost all of the traffic to this internal IP over port 3389. So we know that there's some sort of RDP traffic here. We can then now start looking at Escapee, because Escapee has more details than we can get from the Wireshark PCAP. Again, we run it, and you can see here we get 40,000 results. We should have gotten much more. We could rerun it now with max entries. But we're going to just look at a few entries here. And you can see the Escapee output here. It's not very friendly or pretty or easy to read. So we might want to go and do a little bit of work to manipulate it. You can also see that the IP flag, they use the evil flag, which is actually pretty helpful if you want to filter just and see all the traffic that has the evil flag set. You should be able to see all the attacker traffic. So right now we want to go and run the aggregation, and we're going to do it on Elastic. So what we do, we're going to check out the evil flag. So we're going to query with IP flags set to evil. We're going to do it as a bar chart, and we're going to set a title here. And you can see we can show it as a table. We run it like this. We show it as a table. We can also do it as a chart. And you can see here, these are the source IPs with the evil bit set. And you can see that there are more IPs here, external IPs, that we might want to look at and to see if they're truly evil because they set the evil bit on. We don't typically have that. Attackers rarely use the evil bit in TCP when they're attacking, but in this case we have it. If you go back and we start looking at, we ignore the evil bit and we just look at the message field. As I said, it doesn't look very readable or easy to parse, but we also see that it has structure to it. And that means that we can start using pandas to slice it up. So the first thing we can do, we can just say slice it. So we're going to take the message field. Again, we're going to use this string to convert it to a string and then use operations of the string. The operation that we're going to be using is slice. And slice just takes a string, and you can just say, oh, I'm going to start from the first character and I'm going to stop at the 30th. And then I'm going to do a unique operation to say, show me all of the different message strings that have this particular slice. And you can see that they're all the same. They all start with bound method, package show off, and then something. We can use that and say, oh, let's just remove that from the string. Now we're going to do the message string, and we're going to start from character 30, and then we're going to split on the pipe simple. We can do the expand equal true. That means that it will, instead of having it as a list, it will create a new data frame. And now we have a data frame that looks like this. Slightly split up, still slightly hard to read from. But at least we have something a little bit easier to look at. And we can also do, just look at the transport layer, the first 10 bytes. And you can see here, just by looking at it, There's an ICMP echo request sent, and then there's an HTTPS report, and then there's HTTP. There's another ICMP request sent out, ICMP echo reply sent, and then boom, we get 3389. So you get RDB. So you can see that there's some sort of scanning going on here. And we can even process further out if we want to, and we can try to make it a little bit more pretty. Show you a little bit of functions, how you can do that. And then you can get a data frame like this out, where you can see slightly more clearly what's being done. So we see this. And then now we can go and do another query and say, oh, give me everything where you have both of these IPs. And we're parting of Escapee. Again, we get 40,000 results. We can make it larger if we want to get everything, but we're just showing you how it works. So we can do it again. We split it, we do this, and we can see here. Here's just the traffic between these two hosts. And you can see the ping, the TCP traffic, and then what happens next. So we know that there seems to be an RDP connection from this potentially evil IP. So what we're going to do is we're going to look at logging events. And for this, we're going to be using the analyzers. I was not mentioning that a little bit earlier. I didn't do that. We have in Timesketch, we can run an analyzer on the data. An analyzer can do pretty much everything you can do in a colab and or the UI, but do it programmatically and automatically. So when you upload the data, you can run an analyzer. The analyzer can run a query, and then based on the results of the query, either extract a field, create an attribute, create a tag, add an emoji, whatever it wants to do. So in this case, we can run the logon analyzer, which we did. It will take all the EBTX records, extract all the login information, and save it as an attribute. That means that we have our data more easily accessible. So now we can just say, we can start by just saying, oh, give me everything where we have an EBTX record and we have this IP appear anywhere in it. And then we can get a whole bunch of records back. We can do a quick overview and we can say, give me all the usernames that we found in that particular data frame. And you can see that there's network service, there's an administrator. We can also say, give me all the event identifier or source name. And you can see that these are a lot of them are RDP and logon related. And we can also say just, okay, I want to look at all the logon events where the administrator was the username. And now you can see here, here's the logon event. You can see the timestamp, you can see the source IP, and you can see that these are all remote interactive logon types. So here we have the attacker logging into the system using the administrator account. And you can see the time frame where they're doing that. And now we can look at whether there were any other logins from that machine, from this IP address. And you can see it was only the remote interactive and administrator. What we do here is that we have a data frame back, and we are going to filter it and say, give me only the logon type and the username columns or the fields, and drop all duplicates. Basically, just a unique operation on this pair of fields. So you can see that for that, we only get this one record here. So they only logged in as the administrator. And now we can start looking at some actions on the system around that time. And this is where we can use part of the magic here is we can say, oh, give me everything. So the query is just give me everything, but let's filter it on a timestamp. So just give me everything that happened between 1 a.m. and 4:20 a.m. on this particular day. And you see, you get back, I say max entry is 50,000 here. I get back 50,000 results, but there should be like 925K records. So in this case, I did pull the larger data frame up, which does consume a lot of memory. You can see that now it has 925,000 records. And now you can start looking into it. We can start exploring it a little bit. What data types are available? Okay, you can see that this is a lot of network traffic. the vast majority is of network traffic. And there's a lot of EVTX records and so on. We can start looking at that. We can start grouping it. We can start grouping and looking at, oh, well, give me all the data types where the data type is an EVTX record, and let's group it on event identifier and source name. So we can see that S channel events are the vast majority. And if we ignore them, we start looking at it a little bit further, we filter it out, we can see a lot of RDP connections here. And if we start looking at the RDP connections, and we want to look at the IPs, you can see that the IPs are going to be that evil IP that we saw before. So this is just one of the ways where we can start filtering here, and I hope that I would have more questions by now. But if people are stuck or have any questions, please don't hesitate to send them out. But we can start continue with that. Like now we're going to say, okay, was there any malware use? You know, we know that they did RDP into the system. We know that it came from externally. We know which IP. We still have the data frame with all of the data from that time frame here. So that 3-hour period that we logged in. And we can see that there are actually some here. There's like boot execute, and there is, there's the win logon that we know of. There is some Amber-U, there's some user assist, and there are some execution events here. Windows prefetch execution, for instance, here. And service accounts as well. So first we can start looking at the prefetch execution. Look at the date, look at the executable, and how often it has run. When we run this, we can see, a whole bunch of executables that have been run. We might want to go and say, oh, let's look at only those that have been run very rarely. Let's look at the ones that have a run count of less than 2. And then we can do that, and then we get this list, which is much smaller, and we can see, you can see sc.exe being run. We can see something called core updated.exe being run. OneDrive, and
so Katie, there was this question like, what are the potential homework that people could do after the webinar? And I think it's so that we answered some of the question in our Jupyter notebooks, but not all of them. So if you want to explore the data afterwards, you can just fork the notebook and then try to answer the remaining questions from the scenario with the data that we put into the demo server. So you will have some learning.
Yeah, and also just to run with it, try to understand everything that's in it. If you don't understand anything, ask questions. Use the Slack channel. Ask us questions, and it is much better for people to run through it themselves and then hit some walls and say, hey, why on earth are you using this, for instance, here? Here, for instance, like the filter, I'm going to say, oh, I'm just going to look at this particular data, the records that have this particular data type set. But here, for instance, like this here, what does this mean? This means that I am going to be filtering it based on run count, but run count doesn't always have value because we are a data frame and we might have records that have run count set or not set. And if it's not set to a value, it will fail if I run this without filtering out first the run counts that don't have a value. So here I'm just saying this is basically the not operator, or don't include this. And I'm saying, oh, if it's an empty value or not a number, filter it out. So please do that. Yeah, run through it. Try to answer some of the questions that we haven't answered, because it's like we're only answering part of them, and keep asking questions. So yeah, so SC was being used. So now we can start looking at that. Let's look at that, and we can see here if we run. Again, we're just looking at the source name being Service Control Manager, and we're looking at the strings. You can see here the core updater is being set as a service, and you can see all these other here services that you might want to take a look at a little bit further. So definitely core updater is something that we want to go take a look at a bit more closely. One of the questions was what process was malicious, which is obviously core updater.exe. We found that, we saw that. However, if you actually start looking into the memory dumps, which we haven't included here, you can see that there is another process. It transitions into another process. So you will miss that other process if you don't do memory forensics. But we are intentionally skipping it here and just including the other sources. So you can't answer everything just with the data that we've gathered right now. You need a little bit more than that. So Ryan, are you back up from your machine crashing?
Yes, I am, and always
All
good
right.
to.
Yeah, take over.
Okay, so like we said, we're not going to be able to go through every single question in here. But one of the ones that I thought was interesting that I definitely wanted to walk through was one of the advanced ones where it talked about was any file timestamped. Okay, so one of the things I've always found interesting with cases is when anybody tries to do anything kind of even vaguely anti-forensic, right? So any kind of evidence tampering. And so timestamping is a way where you can modify the timestamp of a file to try and make it blend in as another file, or otherwise kind of throw off any kind of forensic analysis. And so there are multiple ways that you can try to go about this as an attacker. Some of them are very hard to detect, and some of them are not as hard to detect. And so thankfully, kind of in this scenario, this one is one of the ones that wasn't as hard to detect. So as one of the ways that you can do timestamping, kind of the least sophisticated one is when you use an API call to change the standard information timestamps on a file. And so this works, so you can change the file timestamps. But one of the drawbacks of the API is that it only sets it to the second level, whereas lots of timestamps, if a timestamp is generated kind of natively, it has more precision in the timestamp. So what I'm going to do here is I'm going to query for any file kind of results, from the MFT. And if I query everything, I'd pull back a giant data frame, kind of like Kitty did in an earlier one. And so I'm going to filter down just off a guess that it might have some keywords involving some of the things that we found so far in the case. And so for my timestamp query, I'm doing the data type is a file system stat. And so this is what Plaso puts out from parsing the MFT. And I'm also doing these limiting to these kind of search terms. And then I'm pulling back the fields. The in particular file name and the host name and the inode are ones that are important. And so when I run that query, I get back this shape of the data frame tells you I got back 429 rows. So, okay, that's not too many. And then we want to get to the part where I actually talk about doing any timestamping. And so, like I said, the problem or the indicator you can look for in this scenario is that if any of the timestamps don't have as much precision as you would expect. There we go. And so the first way I thought of approaching this is just looking for any timestamps that end in zeros, right? And so there's lots of ways you can do that. The one I thought of was just is that you kind of cast this timestamp value here, which is a number kind of as a string, and then you say, does it end with a bunch of zeros? You could do a different approach, like you could do some like a modulo function, right? So is it divisible by 1,000 or 1,000,000, and get back similar results. And so I run this. So again, this is, as Kitty did in other ones, this is just a filter. So I'm looking at the timestamp, and then I'm filtering this data frame on anything where this value is true. So it ends with this true value, and you get back these 4 rows. Okay, that's interesting. So the 4 rows in the file name, they all are the different SI attributes for the same file name. So Beth's secret text. So that looks interesting, right? There's no fractional seconds there, but that's not everything. So it could be these things can occur for legitimate reasons, like Windows can use the API to change timestamps for whatever reason the operating system wants to. So let's dig a little farther in this. So the MFT reference number, the file reference number, we call it inode here, is 87,111. right? And so we're going to take that, and we got the disk image pretty quickly after the compromise, mostly because it's kind of a little scenario there where you had some quick incident responders. There's a good chance that since this is a Windows system, there's a good chance that you might still have USN general entries that cover that time frame, and that's always a really interesting source of data. So here I'm making another data frame, and I'm querying for just because everything's kind of squunched into one part of the data frame right now, or in Timesketch in one field. I'm just querying for the file reference number. Is anything that starts with this, the inode number or the file reference number. And I'm saying the data type is a USN journal entry. And we get back a bunch of records. There we go. And I'm saying just sort it by time. And so we sort by these fields and we get back all kinds of records, which is cool. And I can walk through these a little bit. I also summarize them down at the bottom. But so just a little bit about MFT kind of internals. You can reuse an MFT entry. Windows can reuse an MFT entry. And so that's what this dash is. So this inode number here is the entry, and then the dash is like the sequence number. So this is the very first time this one was used. It was a favicon, and that doesn't really seem relevant to our case. But if you look through these update reasons, which is why the USN journal why this record was sent, these first three all have the exact same timestamp, and they're kind of, you can read them all together. The file was created, data was written, and then the file was closed. So basically, this is a small file being created. And then a little bit later, we see the file being deleted and closed. So again, that was the life of that favicon, and we don't really care about it. But the next row we have, so the same record number, but then the sequence number is 2. So this MFT entry got reused. And again, it's saying USN reason is file create. And so it's creating this text document. And since we're a little short on time, I'm going to go down to the bottom here. So you can read through all these records, and it kind of paints a really nice picture of what happened with this file. And I also summarized it kind of down here. So the first part was, again, the favicon. We don't really care. The next couple of rows are saying this new text document was created. And then a little bit after that, we have the same timestamp. And they basically together, they kind of look like they show how a file was renamed from one file to the best secret document. And then there's one thing in here about object IDs that I honestly not sure what it is, but it still seems to fit within our timeline. And the next thing we have is data being added to the file, right? So that's probably the actual secrets being added to the text file. And then the last things we have here is basic info change. And this is something you'd see if, for example, basic info like the timestamps were changed on the file. And so that's a pretty comprehensive little trek into what happened, the lifespan of this file. And it's all very consistent too. But then the fun part is, this query again is kind of combining the two queries I did before. So it's pulling back all those file reference numbers that had the timestamped entries, or the suspicious timestamps, excuse me, and then the USN change records, and we're going to put them all together and view them. And this, it's kind of hard to see on this screen. If you make your screen bigger, you can see it a little bit better. But all the timestamps for the timestamp document, the ones that we suspect are timestamped, they all appear at the very top. There we go. Hard to scroll here. Anyway, so they're all these timestamps by themselves. They're saying, oh, this file was created and modified and deleted and edited, all at the very top, like well before the rest of this very comprehensive timeline from the USN journal. So again, that taken with the lack of fractional seconds, it all kind of points towards manipulated timestamps. So that was one little sidetrack into one of the more advanced questions that I thought was kind of fun. And so with that, we're going to go back here. So we finished our demo. All right, so if you guys are still interested, and I hope you are, you can do more questions about this scenario. As Kitty and Alex said, we definitely didn't try to answer every question on here. There are more questions that we answered in the collab than we went through, or in the notebook than we went through, so you can step through those, and we encourage you to ask questions. We also have some questions in there that we didn't get to, right, like memory analysis ones. There's also a lot more stuff to go through in the import notebook, especially around the PCAP. So that was a lot of really interesting work to get the PCAP files into Timesketch. And if you want to do more about kind of like notebooks like Colab or Jupyter, We have more example notebooks in the GitHub for Timesketch that also interact with the Timesketch demo. There's a few other scenarios that we did for kind of along the same lines, and there's also some other notebooks that kind of walk through different pandas kind of things that you can work at. There's also the new Picatrix thing that Kitty talked about to help you as kind of an analysis tool. And then if you want to contribute, we encourage that. We have a Slack, all open source digital forensics, where you can ask questions, you can see if there's things you want to add or work on, and we're always happy to help. If not one of us, we have lots of other members on our team and also from the community in that Slack that we'd love to be able to help you out with things. And then lastly, so again, we'll open up for any questions. If you want to talk, ask a question live, you can raise your hand. If you want to ask a question in the Slack, you can do that now, or we'll be monitoring it kind of forever. So if you have any questions, you can definitely reach out there.
All right, we're trying to answer the questions here on the Slack channel, and it said, like, if you have any questions, just keep coming with them there. We'll try to answer them there, and we'll be monitoring it for at least the next few days. I know that we did go through everything fairly quickly. People might not have had time to really slow down and understand what we were doing, but we didn't have a whole lot of time, and it was hard to maybe move too slowly. But we wanted just to go through a rundown and show you quick some of the options and some of the things that are there. And we're hoping that you can then either rewind the video when they get released, or just go through the notebook on your own time and ask the questions when they come up. As I said, please just run them, go through it, see if you can see something. We also didn't go through any of the virus total stuff that we have here. We're using external API here to query virus total. Just take a look at it, and you can see all that stuff here. So yeah. Any other questions that people have? As I said, please show them on. Type them into the Slack channel. Other than that, I think we should be good to go.
Thank you very much for listening.
Awesome. Thank you, guys. Thank you, Kitty, Alex, and Ryan. Thank you, everyone who joined us. We hope you learned something and found this useful. I know you guys already talked about the Slack channel, so everyone should go there for more questions. Also, as soon as we end the webinar, you will see a survey pop up. It should just take a few minutes to fill out, so we would love it if you did that. Your feedback is really important to us. And if you haven't registered yet for OSDFCon, go to osdfcon.org, and hopefully we'll see you next week. You can also find the upcoming webinars there that we've planned, and we will continue to add to that list. So that's it for today. Stay safe and healthy out there, everybody, and we hope to see you again on the next one. Have a great rest of your day. Bye.